are you preparing students for exams? That is one part. As a tutor, everyone has to do. Second part is to give them knowledge, give them interest. That's why I said marketing your subject. You don't know which student of yours is going to be a chemistry scientist tomorrow. So when you speak in a class, when I am talking to my students, I believe, oh, they should remember Dr. TPS taught me this even when they become the scientist in that subject, right? So not repeated that way. I think the easiest method is take a 10 years question paper. Every exam in this world people can pass, but that is not good enough. So there are three different aspects probably in the tutoring. One is getting marks in exam. Second one is creating interest. Third one is getting general knowledge around this. All the three together puts your class into a class. Always a teacher is a good teacher when you can make students to ask questions. How many questions your students ask you, the more number of questions, you are the best teacher. If they don't have any questions, that means they understood. Yeah, there is no point in asking questions, or you are not making them to think. Two possibilities are. I did my masters, and I did in a very special university in Kerala, which is called the Cochin University, which is one of the best schools of mathematics in Kerala. It was supposed to be an IIT, except for political reasons, otherwise it would have been declared as an IIT. We had a paper what is called algebraic geometry. Whatever you taught is an algebraic geometry. You are visualizing what you are seeing, right? The best applications of algebraic geometry, one simple answer is modeling. Any modeling. Financial change is a modeling. Anything is modeling, mathematical modeling. It could be a surface modeling. Right? Your GPS works. Location is found. Location is found how? There are 6 GPS and you are standing on the ground with, and the distance from your place to those GPS is what is used for drawing a sphere. The GPS, the distance from the GPS to all the places can be the surface of a sphere, right? In a space. You have another GPS which is another sphere. So 2 spheres intersect in a circle. And another GPS intersects. So it can be 3 points, 2 points. So you are pinning it down to 1 point. It's all, every GPS is using the simultaneous equations. Without simultaneous equations, no 3 vectors or 3 equations, putting them together, everywhere it uses. See, once you have got 2 spheres coincide, you get a circle. Third one will tell you where is it. But that will not tell you whether you are on the other side of the earth or this side of the earth, because it is 24,000 kilometers far. Earth is only 6,000. So it can be either this side or the other side. But then we know we are on India. And then we know, oh, this is the XY coordinate, XYZ, with the point, this is where it could be. But to confirm it again, the 4th satellite is used. So 3 points are good enough. 4th point will tell you exactly. But then the whole system is moving. Satellite is moving, Earth is moving. Therefore, we use what is called a differential GPS. Identify in 2 different places. Right? Mark it and then see, oh, this is here, continuously it is in these 2 places. The distance between these 2 is already known to us. Therefore, exactly we can measure. So, it's called a differential GPS. So, all the satellite locations are precisely measured using differential GPS. So 3 GPS, good enough. 4th one, but not one location. From the point, where is it moving? That's always computed on the ground. So 1 ground plus 3 GPS or 4 GPS. That's how it is used. GPS or GLONASS. GLONASS is another one. Each country has got their own name. India also has got, yeah. All of them together. We use, every country share this information because it has to be on top of us all the time, right? So it's always shared and used. 20,000 kilometer height approximately. The topic is actually algebraic geometry. And algebra itself is finite. That's why you have equations. Yesterday it was bound and limit. It is not equation actually. It's like an area. Boundary can be always. And when you have to solve it, automatically you have drawn the picture and says this is where you have to look at. That means it's already bounded. That's why I said the precision. When you wanted to see whether it is crossing here, the obtuse angle or the angle tell you whether you have to look closer or further. Suppose it is like this, then limit becomes easier. Suppose it is like this, you'll have to go closer. Resolution has to be higher. I was mentioning resolution yesterday, right? Assume that your lines are almost parallel, need not be tangent. From farther, geometrically it looks, oh, it is meeting at infinite number of points. But algebraically, solving is easier because it will get exact point. But if it is crossing like this, geometry becomes easier. So what to use depends on the resolution, proximity, the limit, the slope. Actually, gradient is a very technical term. Easier term is y is equal to mx plus c, m is the slope. Slope is a common terminology, right? The gradient is dy by dx, that's a mathematical term. So in textbook they will write gradient. So I suggest people to look at the meaning of gradient. Understood? So then you will come up with the slope. Oh, that I understood. The slope is more, slope is less is more understood by people than the word gradient, right? Good, wonderful. I think the use of your software makes it easier people to visualize it and then understand, right? But then some trivial cases like x is equal to 0, y equal to 0 meets at 0, 0. See, it looks so funny, but people love it, right? So you need not be always x plus m, y is equal to mx plus c need not be there. I can put y is equal to 0, x equal to 0, another equation.
That's true.
So it makes 0, 0. That could be a trivial example which is to be given, so that they find some interest. Oh, this is the way I should write. So everybody draws x, y, and then say, oh, this is what you are doing. And solution is 0, 0. I keep asking lot of questions on my own. If I lecture, I create lot of 10-15 questions, and that's how I start my class. And I find, oh, I did not answer this in my class. Even a philosophy lecture, that's what I do. Simultaneous doesn't mean space alone. It doesn't mean time alone. Time and space. You have to shoot. Space is not good enough. Time is also essential, right?
True, yeah.
So you are not computing where it has to hit. Immediately you should ask when to hit. So it is not 2-dimension. When it comes to 3-dimension, no. 4th dimension. Time also comes as a dimension. Suppose you have to say x square plus y square equal to 2 is, or maybe equal to 9 is a circle with 3 as a radius.
Yeah.
If I say x square plus y square less than 9, that means I am speaking about the area within the circle. Greater than 9 means I am speaking about. So that is also a geometric inequality in which I can visualize it. I can have another equation and solve that together.
Yeah.
So it's not equations alone. Starting with equation is fine. And do you know these subject comes in the branch of mathematics which is called algebra?
Yes.
Yeah.
Not necessarily. It can be, equations can be in analysis. Limit, yesterday Radhika was mentioning about limit.
Yes.
When you talk about number of points in a circle, it becomes infinite number.
Infinite number.
Equation of a line, it is not algebra, it's an analysis.
Okay.
X plus y plus etc 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 up to infinity. When infinity comes, it goes to analysis, it comes to limit. That is where assume that you have a geometry in which we say between this, see you have got um, solving solutions, you use, I have a curve, assume that it's a line, single line like this. I have to talk about the area between this to this, right? Very easy, because this is a line, this is the boundary, and I can solve this solution, and within this what is the area. So I am relating what Kiran said and then what Radhika said yesterday. This is the boundary, right? Now I have a curve like this. I cannot use one line to solve this. I will have to cut this into a triangle here, another rectangle here, another triangle here. Got it? So I have to cut it into pieces. So what do? I am changing my boundary. The boundary cannot be a single boundary and single equation. So I have to solve this into cuts and pieces. So the modeling always use integration to understand the area under that. So x equal to, you have an equation y is equal to 2x plus 3. So x axis, y axis, say x equal to y. What is the integral? X square by 2. What is x square by 2? Do you know integral of y, x dx? You will get x square by 2. What is x square by 2? Actually, that is the triangle area. So what is integral? Within the line, what is below, the area is what is being computed. Got it? So it can be done only when it is a line. If it is a curve, what you will do? You cut it into pieces. Then solve here, solve here, solve here, solve here. So each of them becomes equation. So number of equations become more, it becomes analysis. That's where limit x tends to 0, y tends to 0, etc. will come. Got it? So these are all geometrically you can visualize on a same Cartesian coordinate. Multiple equations can be seen together. That's called simultaneous equations. Not necessarily geometry. It can be huge. It can be inequalities. Okay. So each word by word, when you take it, this question will come. Is there only equation? Why no equations are not possible? Inequalities are possible. Correct? So don't skip, oh, equation is a normal word. Every word mathematics equations are there. Don't skip like that. That's why I want every term by term ask a question. Is there a negation for this? Is there an antonym for this? Is there is a synonym for this? What does it mean? So you feel, oh, as I know the subject I am talking to, with mastery in the subject. You will enjoy. A lot of applications, every modeling, any mathematical modeling. See how many questions I can ask on each topic,
Yeah.
So creating questions. And when you can create questions, your students also will start asking questions. If you think that I have nothing to ask, students also will not ask anything. I don't know how many of you have seen that movie. A beautiful movie came. Physics Wala.
No, I didn't see.
Yeah, there is I think all of you should see that movie, Physics Wala. That's a philosophy. That's like a thinking in that mode, See, many people learn algebra without imagining. See, for example, if I give you an equation, you can write it, but I will imagine. x square plus y square is equal to 9, and I am giving you x equal to 0. Solutions are simple because I know it's a circle and 0, there will be 2 points it is meeting, right? But instead of that, if I say x equal to 5, if somebody tries to solve it, actually they are foolish because they are not imagining. X equal to 5 is a line
So,
little away, no? It's at 5, but my circle is over at 3. So how am I able to not trying to solve it, substitute and saying at the end no solution? Because I have not imagined. Geometry is not in my mathematics. I am only doing it as a algebraic equation. So when you write an equation, how well you imagine the geometry, that ability is really mathematics. Visualizing like a drama, that is true. I am a good teacher in English. I take classes in English as if I am in a drama.
Recording in progress.
That is because I visualize. If you are visualizing, you are a great teacher. Either in maths or physics or chemistry, it doesn't matter whichever subject is it. So algebraic geometry give you that ability to visualize. Limit and boundaries, right?
Yes.
You are seeing a curve there.
Yes.
Assume this is my boundary, these two.
Mm-hmm.
I have a line which is going up,
Yes.
but I don't
So
know
that-
within that boundary whether it is coming down or not. So I will have to
Yeah.
take a bigger boundary. Then I find,
Yes,
oh,
correct.
it's going up and coming down.
Yes.
Then how do I know where is it coming down? Only when I split into two.
True. Yeah.
And then see, oh, one place it is going up, other place it is coming down. So I am looking at same curve more closer to know where is it coming down. Then what do? We again split it into two and see, oh, it's not going up within this, but it's going here. It's not going here, but it's going here, right?
Yes.
It's going here, but not going. So I am going closer and closer to look at how is it behaving.
Behaving. Yeah.
Okay, there is a great integral called the Stieltjes integral, I think. Riemann-Stieltjes integral,
Okay.
in which we use this iteratively look at it. Where is it going up? Where is it going down? So it's easy for us to compute. Again, as no, 99.99999% of the teachers don't even understand this. Got it?
Yes.
You have to think, ask question yourself,
Yeah, that
discuss
is
with somebody else. Then you realize, oh, this is how it is. I enjoy learning maths. I enjoy thinking about it, realizing it, seeing it, question, visualize. That's what I do. I sometimes I teach maths without slides, without a board. All my lessons teaching on online was without a board, without PowerPoint, without. I'll just blah blah blah.
the thing.
And I want the listeners to draw and show me what they have drawn. Then I will correct. No, this is not how it should be drawn. So if I can communicate mathematics, that's what happens in examination, right? The questions are given in sentence and the students are supposed to visualize it and then draw.
Yeah.
That's the ability for a good student. Mathematics in words have to come to geometry, equations. നമ്മളും നമ്മളോളവും ഞാനും അതിൻ്റെ പാതിയും ചേർന്നാൽ 100 ആവുമെങ്കിൽ ഞങ്ങൾ എത്ര? നമ്മളും നമ്മളോളവും അതിൻ്റെ പാതിയും ഞാനും ചേർന്നാൽ 100 ആവും എന്നാൽ നമ്മൾ എത്ര?
3i.
No, if I am x, നമ്മൾ is x,
Okay.
then നമ്മളും നമ്മളോളവും, that means 2x.
2x. Yeah.
Okay. അതിൻ്റെ പാതി is x, so that means it is 3x. ഞാനും ചേർന്നാൽ 100 ആവും. അപ്പോൾ 3x plus 1 is 100. So what is x? It is 33.
Yes.
There NIC had a collection of essays on history of mathematics. nic.gov.in. Heritage mathematics. ഇഷ്ടംപോലെ.
ic.gov.
ഇന്ത്യൻ ഹെറിറ്റേജിനെ കുറിച്ച് അറിയണമെങ്കിൽ കുറേ ടോക്ക് എൻ്റെ തന്നെ ഉണ്ടാവും. ഇന്ത്യൻ സയന്റിഫിക് ഹെറിറ്റേജ്, സാൻസ്ക്രിറ്റ് DrTPS. അല്ലെങ്കിൽ പക്ഷെ കുറേ ശ്ലോകമായിരിക്കും.
വീഡിയോയിൽ തന്നെ നോക്കിയാൽ മതിയാവും.
ഹെറിറ്റേജ് ഉണ്ട്. ഇന്നിപ്പം ഞാൻ പറഞ്ഞ ഹാവ് യു സീൻ ആറ്റംസ്? ആറ്റംസ് കാണാൻ പറ്റുമോ എന്നുള്ളതാണ് ചോദ്യം. ജലാന്തരഗതേ ഭാനോ യത് സൂക്ഷ്മം ദൃശ്യതേ രജഃ തസ്യ ത്രിംശത്തമോ ഭാഗഃ പരമാണു രീതി സ്മൃതഃ. ജല അന്തരഗതേ ഭാനവ്, ഒരു ബക്കറ്റിൽ വെള്ളം എടുത്തിട്ട് ടോർച്ച് അടിച്ചാൽ വാട്ട് യു വിൽ സീ ഈ സ്മോൾ പാർട്ടിക്കിൾ മൂവിങ്. ദാറ്റ് ഈസ് കോൾഡ് രജഃ. ദാറ്റ് ഈസ് ഈക്വലൻ ടു ദ ഹെയർ തിക്നെസ്. Suppose you have a hair, cut that hair the length equivalent to the thickness of the hair. That means hair becomes a dot. Tasya trimshatamo bhagaha, divide that into 300 pieces. You cannot divide, you can imagine. And if you can imagine that, that is the size of an atom. That's called rajaha. Tasya trimshatamo bhagaha paramanu didismrda. That size is called paramanu. And next question is, the poet is asking, are you able to see? Then if Prakash says I am not able to see, one more line will be added. Jnani nam drishti gojaraha. If your buddhi is working, then only you can see. That means the ability of a student is to visualize. See, that gives the ability of a student is to visualize. If you are not able to visualize, you can never learn. So beautifully explained, you know. The Vedic mathematics assume that you have simple ആയിട്ട് പറഞ്ഞാൽ you take a paper, draw two lines, parallel lines, right? And crossing it you draw another three lines. Now you what is that you have drawn is 2 into 3. Two lines,
yes.
2 lines and 3 lines. How many nodes are there you count? You will get 6.
6 here.
So 2 into 3 is 6. So how do you make people to understand this? 2 into 3 is 6. You don't have to
6.
Now you wanted to do 32 into 43. You draw 2 lines, little away another 3, little away another 3, and then count this and count that in the diagonal. Then take from the left to right. Same what we have done in our classes. Geometrically you can visualize. Okay.
Okay.
Now you write 5. What is the square of 5?
25.
25. What is the square of 15?
225.
You write 5 with a dash 25. 15 with a dash you write 225.
Yes.
25,
25.
625, 35,
1225.
1225. Now if I keep on increasing you will have confusion, right? You don't have to, because in Vedic mathematics there is a sloka which says ekadikena purvena. That's a sloka. What does it mean? Only for 5. First when it ends with the 5 you write 25. If it is 35, take 3, add 1 to that, that means 4. 4 into 3 you write as 12 and 25. So what is 45 square? 4, next number is 5. 5 into 4 is 20. 2025 is the answer, 2025. So 55 square will be?
Yeah.
55 square will be?
60, 30, 25.
30,
30,
25.
25. Yes.
45 square will be?
20, 25. So, 45 square, right?
Yeah. 20,
Yeah,
25.
25.
Correct.
Yes.
65 square will be?
42, 25.
40 to 25.
40, 25. So this is what one sloka they have explained. So there are so many such tricks. Only tricks for small computations and calculations, not for great things.
Okay.
Little geometry and little algebra at a minimum level people can learn much little faster. That's all what it means.
Faster.
Yeah. Can do solve problems with a little faster.